Hey, this is Mr. Aiden. This is the 2022 AP Chemistry Free Response number 7. This is the one you've all been waiting for. Yes, that scary question B number 3, the last part of this 2022 exam, which is really not a good question. I believe it should be thrown out. I don't think it's fair for students, and I don't think it is a good question to evaluate chemical thinking or chemical knowledge. But this is the 2022 exam done on May 2nd, and this is the last of the 4-point problems, question number 7. If you're a teacher or you're a student, check out MrAiden.com. I got hundreds of resources, thousands of resources available to you for your response questions, multiple choice questions. But here we go with number 7. Number 7 starts off in question A with identify the hybridization of the valence orbitals of the carbon atom. So take a look at this oxalate ion. The carbon, you can see, has 1, 2, 3 bonding sites. And so with 3 bonding sites, what is the hybridization of 3 bonding sites? It is S1P2 or sp2. And that was question A, the hybridization of the carbon atom. Let's take a look at question B here. Question B, B1. You can see we have silver oxalate, Ag2C2O4. The first thing I want to do is, it's a KSP problem, a solubility product. I want to write my balanced reaction for the dissolution of the Ag2C2O4. So we have, here we have Ag2C2O4 solid, and that is going to be in equilibrium with 2 silver ions, Ag+, plus the C2O4 -2, and that's what it would break up into. But they wanted the KSP expression, and the KSP is 5.4 times 10 to the -12. So what is the KSP expression? Our KSP is going to be equal to, you can see, the KSP is going to be equal to the concentration of silver ions squared, because it's 2 moles, times the concentration of C2O4 -2. Okay? Excuse me. And we're next going to find the molar solubility in distilled water. So this is not a common ion problem. This is distilled water. We know the KSP was given. We're looking for the molar solubility, which is X. The KSP is 5.40 times 10 to the -12, and that's going to be equal to 2x squared times x, because it is a 2x to 1x ratio, the 2 silver ions to the 1 oxalate ion. And I'm going to make sure you can see this. This is 5.40 times 10 to the -12, which means this is a 4x cubed problem. How are we going to do this algebraically? Divide by 4, cube root it, and that gives you what x is. And x ends up being, when we do all of our mathematics on our calculator, 1.11 times 10 to the -4 molar. And that's what x is. Now, what is x? That is the concentration of C2O4 -2. It's also called my molar solubility. That's how much can be dissolved in solution in distilled water. We could find our 2x, which is going to be double, 2.22 times 10 to the -4 molar. And that is the concentration of silver ions at equilibrium. And so we can find x, we can find 2x, we can find the molar solubility. They were looking for the molar solubility here. Now we're going to be moving on to our question number B3. Yes, the question that is everyone wants to know about. All my students came back and they were talking about this question. We're trying to find, you can see here, the molar solubility of Ag2C2O4 is going to increase. So again, I'm going to write my balanced reaction. Ag2C2O4 solid breaks up into 2Ag plus aqueous plus a C2O4 -2 aqueous ion. Okay, and we want the molar solubility to increase. So according to Le Chatelier's principle, we want more of it to dissolve. We want our reaction to shift towards the products. Now, the way we shift towards the products is we have to remove one of these ions. We're going to have to remove the silver ions from our solution in order to move this way, or remove the oxalate ions. And that will shift our reaction, according to Le Chatelier's principle, to increase the molar solubility. So how are we going to do this? Well, you can see they're adding HClO4, which is called perchloric acid. So you might have had 2 different options that you were thinking about. We're supposed to write a balanced net ionic reaction for what's going to happen. So think of our 2 options. Our first option is to take this this strong acid of HClO4, and remember that HClO4 is a strong acid, which means it's going to dissociate 100% into ClO4 minus NH plus. These ions, it's going to dissociate. I'll write that this here. I'll write this here. It's going to dissociate 100%. 100%. It breaks up 100% into these ions. And so, let's say this H plus ion reacts with the C2O4 minus 2 ion. And we have 2 moles of that because we have the balance of charges, and that would make a possible weak acid, H2C2O4 aqueous, and that weak acid will not dissociate very much. Or that Ag plus ion would end up reacting with the ClO4 minus ion to make AgClO4 solid. Okay, sorry, that's not a minus there. That is just a 0 charge, and that's a solid. So we could make a weak acid in one net ionic reaction, or we could make a precipitate in the other reaction. Well, the interesting thing is this. This was a gotcha question because ClO4 minus is like nitrate and acetate. It is always a spectator ion. And what the College Board was doing was going, did you memorize that this is always, this ClO4 minus ion, that this is always a spectator ion? And the College Board, AP Chemistry, I was a pharmaceutical chemist, I was a pharmaceutical lab manager. We don't memorize anything in the real world. It is all about problem solving and chemical knowledge. And this does not evaluate your chemical knowledge. This is a gotcha question. Because HClO4 perchloric acid, you can't buy it from Flynn as a teacher. You can't buy it from Flynn Scientific. You don't have it in your lab. Students have not used it. This is a bad question, and it should be thrown out. ClO4 is always a spectator ion, so you can't get a precipitate. This will not precipitate. So the correct answer is the weak acid reaction because the ClO4 minus is always a spectator ion. Now you might say, Mr. Aiden, how in the world could they have asked a better question? A better question would have been not trying to find out this weak acid, which if we look at the Ka of this weak acid, it's 1 times 10 to the -2. It's not that weak. It is not weak at all. It is a highly dissociated ion. Okay? It is going to shift it very, very, very little, which means this is a gotcha question. So my students asked, what would have been a better way to ask this question? A better way would have been an open-ended question to a student saying, what aqueous solution could a student add to increase the molar solubility? Well, let me ask you. That gives it more of an open-ended question. They could have used a strong acid, or they could have said, add sodium chloride aqueous, something that every student has in their lab and in their kitchen. And that would have made Ag plus and Cl minus makes AgCl solid. That's a precipitate. That would have removed the silver ions. That would have pushed the reaction, shifted the reaction to the products, and you would have gotten an increased molar solubility with a substance, a solution that is in everyone's kitchen. Not a substance you can't buy from Flynn Scientific. A substance that no student has ever used before. So this is a bad question. It is a gotcha question. It is a, did you memorize this? Or did teachers teach this and have students memorize it? It is a poor question. We should be, as the rest of the test does, a very good job of testing your scientific or chemistry understanding. And this last question should be thrown out, I believe, by the College Board. But, you know, that's what they paid me the big bucks for, is to change questions. No, they're not going to listen to me. It's okay. So anyway, other than this very last question, it was a great exam. The 2022 AP Chemistry exam, a great exam. And this was question number 7. I really appreciate you coming to my YouTube channel. Check out my website again at www.mraiden.com. At a reasonable price. I have so many resources available to students and teachers that don't have you memorize, but has you really know deep understanding of AP Chemistry. Thanks for visiting. Take care. See you later.